Here we go with our last section in lesson 7, waiting for a waiter. You'll see that I also still have my probability calculator open, and I set it for the information that we have here. So the wait times at a popular restaurant are approximately normally distributed. The mean wait time is 24.3 minutes with a standard deviation of 3.2. So the average person waits about 24 minutes for their waiter to come, I guess, from the time that they walk in the door to be seated for a waiter. Seems like a long time to me. Use technology to estimate the wait times for the described group of diners. Okay, so what's cool about this, we're going to see this here. Describe the number of minutes diners have to wait if their wait times are in the longest 10% of wait times for diners at this restaurant. Okay, so I'm going back to my probability tool, the calculator that they have on IM, and I've already set the mean and the standard deviation. Now, if I'm looking at the longest 10 minutes of time, I want everything at one value or higher. Okay, so I can see this. Now, I can do this in a couple of different ways. I can use this like a little slider, and I can just be like, well, hey, I want to cut off about 10%. Now, I'm looking here at the probability box, okay, what the probability of this thing happening is. And so I could slide it down till I'm about at 1.0. Got really close there. It's actually pretty good right there. Either of these two. Or I could even actually edit that probability box. If I want 10% of the people, I can just put in 0.1. And then when I hit enter, oh, that's going to give me 0.36. Oh, it should be adjusting my time, but it's not. That's so weird. It can only get me, I guess, so close. So I can see that by getting it at the 0.10, as close as I could to that, using that slider or our probability amount, that we're looking right here about what that time would be for people. So we're looking at people that wait about 28.4 minutes. Okay, so what we did is we set on our scale, we wanted that probability, and this is how they would write it, to have our x be greater than or equal to something we don't know to equal 0.1. Okay, so that's that probability that we're looking for. Sorry, you couldn't see that when I was writing it underneath the screen. All right, that time that we're looking for, that cutoff time that tells me the biggest 10% of people underneath that curve, the area, estimating how many people that would be, we said it was 28.4 minutes. Now notice that there's not a whole lot of work that we can show to do this because it's all done using technology right here. Okay, the empirical rule helps us make an estimate. A calculator like this helps us get really specific. Number 2, describe the number of minutes diners have to wait if their wait times are in the shortest 15% of wait times for diners in the restaurant. So again, I'm going back here, and now I want the shortest. So I want an amount and everything lower than that amount. So I want to use this first kind of cutoff. So I'm looking at an amount and lower. And again, I'm going to slide it. I am going to try this again because I thought it worked at one point. I want 15%. Oh, there we go. And so it then made that change for me. And I can see that it made that 15%. There's that shaded portion here that's telling me I'm looking at about 15%. And it would be 20.9 minutes, or it's so close. Look at how close that is to 21 minutes. So the shortest means they're waiting from 0 to 21 minutes. So that's the shortest. So this must be one heck of a restaurant if the shortest 15% of people are waiting up to 21 minutes to get there. Pretty amazing. So to find the wait times, let's go back to our view here. To find the wait times for the middle 50% of wait times of diners, draw an example of a normal distribution curve. Shade approximately the middle 50% under the curve. All right, so we're going back to what we had in lesson 6. Draw your curve. Drop your mean right in the middle. Our mean is 24.3 minutes. we're going to divide the rest of the area into roughly 3 standard deviation segments with just a tiny itty bitty tail sticking outside there. Each one of these segments has a standard deviation of 3.2, so we could add 3.2 to each 27.5, just adding 3.2 to this. And subtracting 3.2 would get us 21.1. And again, we could do that again and again. Our empirical rule told us, and we're looking for the middle part here, that this section is 34%, this section is 34%. Okay, so if I colored in that full standard deviation, one above and one below, I'd be at 68%, and that's too much. I don't want that much. It tells me I want about 50%. So I want less than 1 standard deviation above and below. There's my shading. We're looking at something that is about that much. So what percent of the total area is unshaded to the left of the region you shaded? What value marks the line between the shaded and unshaded portions? And then the area to the right of the region that you shaded. Well, we got to figure this stuff out, right? So I'm going to go back to my probability calculator. I still have the same mean and standard deviation set. No biggie. I want to have a range here in the middle. And I want that range to be at 50%. Thank you. It wouldn't give me a value. Guess I can type in there. That's so weird. So that range in the middle, I'm going to need to actually kind of manually use these like sliders until I can get about there. I know it's going to be less than 27.5. Okay. So I know it's going to be somewhere about there, and I know it's going to be more than 21.1. I'm just going to try to evenly kind of balance these to get about 50%. I don't think I'm going to get much closer than that. Right? So I'm looking at 50% from somewhere around about 21.9 to about 26.2. Okay. So if I have 50% shaded here, I'm going to use some of those values that are helping me this idea. So to mark that line between the shaded and unshaded to the left of where I have it right here, it's saying, hey, what is this dividing line right here? And that line that we have is about 21.9. And if you know me, you know I'm putting an ish there. Okay. It's about 21.9-ish minutes. And so then I can also mark this idea about what line is at my top end. That's question C. And taking it here from my value 26.2-ish minutes. Okay, so I can use those values kind of as some cutoffs. All right. Now, it asks me what percent is outside and outside. If this is 50%, covering that up, everything else here is 50%. Okay, so if half is shaded, half is not shaded. So if that stuff there is 50% and I need to divide it into 2 equal segments, that means 25% is over here and 25% is over here. Watch that part again if that didn't quite make sense, right? If I got 50% shaded, non-shaded is also 50%, the other half. And I need to split that half in half. So we're talking about 0.25 or about 25% in each of those 2 portions. And so the shaded region is between which 2 values? That would be from about 21.9 to 26.2. Last but not least, the diners who have to wait in the middle 70% are between which two values? This is what I love about the empirical rule. Okay, empirical rule told us 68% is right here within one standard deviation. It wants just a little bit more than that. It wants 70%. Okay, so I know I'm going really close to one standard deviation above and below to get to 70%. So I'm going to put it about 27. Let's just see what we're at here. 27.5 is one standard deviation above. 21.1 is one standard deviation below. Hit enter. Look, we're at 68%. So if I maybe nudge each of these to like, that's way too much. Man, even just rounding up and down is like, that's pretty darn good. Look, I got it 69%. That's darn close to 70. Okay, so I would be looking from about 21 to about 27.5 minutes. All right, so this is a pretty tight standard deviation going on here. There's not a whole lot of difference between that 50% here, 50% here, these values, and 70% here, these values. Now I just want to do a real quick look at the Are You Ready for More portion. Okay, I'm going to go through this pretty fast, and I'll actually even make my screen bigger so you can see more of what's going on here. It just gives us some normal curves, and I rewrote what our empirical rule told us, that 34% in the first standard deviation, 13.5, about 2%, and about 0.5% outside. And it asks us to draw two different regions that have approximately the given area and shade them in on the grass provided. Okay, so number one is saying 68%. Well, 68% is these two middle portions right here. Okay, so one way I could do this is to go with one standard deviation above and below the mean. It told me that the mean is at 100, standard deviation of 10, so I've got it from 90 to 110. That is about 68% of our data. A different way to show that, well, let's see, if I went from here to here, from 0 to 100, that's half of our data. Now, I don't want to go a whole another 34% because that would be 84%. But if I just go just a little smidge more, that would also be about 68% of our data. Now how about these ones that talk about the area of being 0.16? Well, 13.5 plus another 0.5 is 14, 15, 16. It would be these top three portions. So everything higher than one standard deviation above the mean would be about 16%. And everything less than one standard deviation below the mean would also be about 16%. See how much balance we have going on here? A lot of symmetry happening. Last but not least, if I'm thinking about something that would be about 10% of our data, there's a lot of different ways that I could do this. Okay, I could say, well, we need something that's roughly a third of the middle standard deviation. That right there is about 10% of our data. Okay? Or I could do it, from an end going on here. So right here we're at 2.5. If I had this whole thing, it was 16%. That was way too much, right? So I don't want it to be all the way up to the 90 here. But maybe if I went to somewhere around like 85, that would also be about 10% of our data. Pretty cool. So in our lesson 7 summary, you may want to write down these steps that I have written down here. So hit pause on this video if you'd like this information. Using our IM tool, we went to the probability calculator online, And we entered these steps to find our values, right? We entered the mean in the mu, the standard deviation in the sigma, which shows our interval type. We either set our interval values if we knew them, or we looked at our probability value and we used our sliders. Okay, so setting our probability value, those ideas of using the sliders. And then we could either read the interval or the probability that we were looking for. Good stuff.